Thank you very much, Tourbillon, for the great talk about the challenges that are still remaining in speech recognition and speech technology. I will start with the code switching. So I'm switching to English for this presentation. And my goal is to give a very quick overview of the activities that we have at NTNU and the way we are trying to address at least some of these challenges that Tourbillon was talking about. And most of the examples I'll show are from 4 projects that are in collaboration with Tourbillon. I will give quite many examples. That's very short time, so I won't go into any details, but I will give references in case you want to learn more about each of the examples. Also, we have chosen, as Tourbillon already mentioned, 2 examples that will be described in much more details by Phoebe and Janine, that are the PhD students that work with these topics. And all these projects, so the ELADA and the Nordtrans project has just finished, but we still have PhD students that are actively working in them. So that's why they are included here. The thematic areas are mainly, we try to focus on specific target groups, as Tourbillon mentioned, that are often underrepresented by current technology, for example, children, being them native children or foreign children learning a second language, or speakers with some form of speech sound disorder, so pronunciation that deviates from native speech. We also focus on dialects for Norwegian in particular, and on conversational speech that is more spontaneous and involves several speakers that are concurrently speaking at the same time. We don't only focus on speech-to-text, so transcription, but also we use this quite powerful models for other tasks, for example, pronunciation assessment in computer-assisted language learning. I'll come back to this very soon. Also, we focus quite a bit on assessment metrics. We have seen some examples of how to measure performance in terms of number of word errors, but we can do better than this. We can analyze errors in more details, and we can also try to include semantics in the analysis, as Janine will talk about later. Finally, we do quite a bit of data collection, or at least we assist in data collection. So the first project I'll draw some examples from is ELADA. This is a Marie Curie Innovative Training Network funded by the EU. And the focus is on computer-assisted early language acquisition, so developing technology to help foreign speakers to learn a language. And at NTNU, we've been focusing on speech recognition for child speech, and the PhD student that has been working with this is Zijan. And the challenges, as Tourbillon already mentioned, are mainly the data scarcity. So we are we cannot dream of the hundreds of thousands of hours of speech recordings for this task, but also the large variability in child speech, both because of the acoustics of the speech signal, depending on the different anatomy that children have compared to adults, but also large variability in behavior, as you have heard from the examples. So there's a lot of hesitations and non-grammatical speech and so on. And in the first study that Zijan has done, because of the data scarcity, so one thing that we can do when we don't have data is to use knowledge that we already have. So he applied some knowledge-based speech signal processing techniques to transform the large amount of adult speech that we do have to make it sound more like child speech, and therefore augmenting the amount of training data for child speech recognition. And the limitation, this gives some improvements, but of course the limitation is that we can only address the first kind of variability, so the variability in the characteristics of the voice and not in behavior. So in a later study, he has been using one of those foundation models like Whisper and try to fine-tune. So these models have been trained already on massive amounts of adult data, and then he has been developing methods for fine-tuning Whisper to child speech. And even for fine-tuning, you saw from Per-Egil's presentation, fine-tuning for Norwegian took several tens of thousands of speech data. Here we are talking about minutes of speech data. So one way of trying to improve the situation is to try to find groups of speakers that are more homogeneous. So we can group them together in the training data and get a slightly larger amount of data for every group. But still, the model needs to learn behavior and voices that are more homogeneous with each other, so that we reduce the variability. And Zizhan has been doing this in two different ways, either by considering the actual age of the children, finding optimal ways of combining age groups. Of course, this has the disadvantage that then you need to know the age of the speaker when you want to recognize them. And the other way is to just do speaker clustering, so to group the speakers just according to their characteristics, their similarity. And you see in the plot here that one of the clusters, the blue one, is related to, contains mostly older children, but the other clusters are not really dependent on the age. It's only dependent on how the children sound. Moving on quickly to the second project, this is called Teflon, and it's a Nordforsk project, so it's a collaboration between many institutions in Finland, Sweden, and Norway. Again, the focus is on computer-assisted language learning, so, and also for children. So we focus on young immigrants to the Nordic countries that need to learn the language in order to improve their integration in the societies, and but also on native speakers that have some form of speech sound disorders, so deviations of pronunciation from the more native pronunciation. And in this case, we look into two different applications of the technology. The first one is speech recognition, again, transcribing those children. And the second one is pronunciation assessment, trying to give some feedback to the students on how well they are doing in pronouncing. In this situation, there was absolutely no data when we started the project. So one of the big contributions of the project has been data collection. And here you can see in the table that we have collected 5 different data sets. 3 of them are for second language learners of Swedish, Finnish, and Norwegian, and 2 of them are for Swedish children with some form of speech sound disorder. And we're also showing how we can use this data to produce some automatic speech recognition and automatic pronunciation assessment. So the other contribution is proposing methods how to use end-to-end speech recognition models to do at the same time the recognition, the transcription, but also an assessment on how good the pronunciation is, which are quite orthogonal kind of problems. But then we also looked, so this is kind of assessment of the pronunciation that relates to the whole utterance. So we can only give a score for the utterance. So Xinwei, that is the PhD student that is working at NTNU in the project, has been looking also into giving more detailed assessment of the pronunciation, so for each phoneme, so to tell the learners exactly what they pronounced wrongly, and this is called goodness of pronunciation in the literature. And 2 of the contributions of Xinwei, the first one is showing that for children this traditional goodness of pronunciation is not very reliable, because children exhibit much larger, even native children exhibit large variability in pronunciation compared even to foreign speakers or adult speakers. So it's very tricky to determine what is acceptable or not in this variability of pronunciation. The second contribution is to propose some ways of using modern speech-to-text technology, end-to-end systems to perform this task, and also to address some of the shortcomings of the standard GOP, that is, for example, sensitivity to alignment of the target segment that we are trying to evaluate, but also the fact that standard GOP only considers substitutions as pronunciation errors. If you do a complete deletion of the segment or an insertion of a new segment, this is not possible to assess. Still, very quickly, moving forward to the third project. This is it's called Scribe, and it's IKT Plus project funded by the Research Council of Norway. And besides NTNU, we have NRK, the National Library, and Telenor as partners. And here we have focused more explicitly on Norwegian speech recognition, focusing on conversational speech, dialects, metadata extraction from speech, and also metrics. And as I mentioned before, Phoebe is going to go into some details about this work on error analysis. So one thing that we're really interested in is not just measuring how well the recognizer performs in terms of word error rate, but also try to understand the kind of errors that these systems produce, and in particular, depending on the different dialects. So she will go through some of this. She has always been working with trying to understand what features human listeners, but also AI systems use in order to distinguish between the different dialects. And I think she will mention this as well. This was in collaboration with Hemming, that is our postdoc in the project. Also, this is something that you will hear more about from Janine, is the attempt at introducing better metrics for evaluating speech recognizers, and in particular, how to use large language models to introduce semantics into the evaluation so that we don't count any error the same the same importance. Another contribution of the project is the collection and preparation of quite a few data sets that you see listed here. This was in collaboration with the National Library of Norway and with Språkbanken. And it's really nice that we could make all of this publicly available, and it's also been important for the work that Per Egil was showing on fine-tuning Whisper or training Whisper for the Norwegian language. Also in this paper that I show here, we have been showing that it's more important to introduce diversity in the training data rather than just increasing the amount of training data. So we want to have more dialects, more diversity in the speakers, the speaking styles, and so on. That improves much more the models than just increasing the amount of data. The last two examples I will make are on conversational speech, and as mentioned already before, the problems with conversational speech are essentially that we have multiple speakers, often recorded by the same microphone, so possibly overlapping. It's more spontaneous, so we don't speak in a grammatical way necessarily, more repetitions and hesitations and so on. We have a lot of signals that we use for turn taking to make the other person understand if they can start talking or not. And so Simon has just started his PhD, and in his work, he has been looking into, during this master thesis, he has been looking into using cross-attention to model this interaction between the different speakers in a conversation to improve transcription for one speaker, also based on the information from the turns of the other speaker. And the final example is from František. that has been working with speaker diarization. That is the problem of trying to determine how many speakers there are in a conversation and also assigning each utterance to the correct speaker. And this is very important when you make transcription because you need to know who is speaking to assign this. This publication just came out yesterday, so it's very fresh. Yeah, so just to conclude, that time is up. So we focus on less represented user groups, which mean children, second language speakers, speakers with some form of speech sound disorder, dialects, and so on. We try to learn from the mistakes that this AI system produce. So try to understand this is both to try to understand how the models work, but also how to best improve them. But it's also important because we can use these systems to try to understand the problem better. So what is it that makes, for example, dialect recognition hard or child speech hard? And finally, we are trying to contribute to open science and try to share all our results, both in terms of data, models, and methods that we developed. So that was it for me. Some people and a rather long list of references. Thank you.